Hello model railroaders, it's Dave, welcome back to the layout. I had a friend ask me to help him out with a problem he had. He has, I should say, a bunch of these incandescent light bulbs. I believe they're from some kind of a Christmas decoration. It's a battery operated decoration appliance, whatever you would like to call it. It runs off of 3 AA batteries, so it's using 4.5 volts. Now he did try the bulb on a 12 volt power supply and the bulb blew, so we know that it is a low voltage bulb. However, he wants to run it off of a 12 volt power supply because he's very much into Craftsman model kits and he models in HO, and he wants to use these bulbs to light his structures. Now he doesn't necessarily need them at the brightness that they light up at 4.5 volts, but we'll deal with that as well as we proceed. So the big question is, for him to use these bulbs on a 12 volt power supply, what resistor value does he need to add in line to bring the bulb voltage down so that it won't blow? So the way we're going to do this is, these are the leads from a 3 volt power supply, and I say 3 volt because we're reading 4.8. Now that's good because 4.8 is pretty close to the 4.7 that I used that it was reading when I calculated it earlier, when I figured all this out for him. However, if you're using a 3 volt power supply, don't depend on the fact that it is actually 3 volts. As you can see with the proof right here. So we're reading voltage. One lead is connected up to one end of the power supply cord. The other lead, the common lead, is connected up to the other, positive and common, and we're reading the voltage across the two cords, which is 4.8 volts DC. Now, to calculate out what resistor value we need to know the current that this bulb uses. So we need to determine the amperage, or in this case, since it's a very small bulb, the milliamps of the bulb. So let's run through how to do this. So shut the supply off. I'm going to disconnect one of the leads. I'm going to change the red lead from the voltage side to the amp side, and I've got it set to 10 amps. You always want to go with the higher amperage. Now when we do the reading, will read DC milliamps when we get to that point. So what we need to do, unlike voltage, the multimeter has to be in series. When we were measuring voltage, we were measuring in parallel. So in measuring in series, we're going to come off the power supply line, go into the multimeter, come out of the multimeter, and connect to one end, if I can grasp it, to one end of the, let me grab the other wire if I can. A little hard to do sometimes one-handed in film. Okay, we've got the other wire. Now, what we need to do to complete the circuit, so right now the multimeter is in series because the power is flowing from the line coming from the power supply into the multimeter, out of the multimeter to the line leading into the incandescent bulb. And let me reach over, and I'm going to grab another set of leads to go from the opposite side, or the exiting wire coming from the incandescent bulb, and then clip into the other lead returning to the transformer. And as you can see, the light has lit. Now, with our multimeter on DC milliamps, we'll turn it on, and we're reading 0.04 amps or 40 milliamps for that bulb to light at, it was 4.84 I believe, but we'll go with 4.7 volts that I previously measured in my calculation. So what we need to do to find out the voltage, the resistor value for a 12 volt power supply is, we use the equation E equals I times R, or voltage equals current times resistance, or voltage equals amps times ohms. So to know our resistance, we then divide our voltage by our current. Now we want a resistor to remove voltage from the series circuit. So we don't want to use 12 volts as the voltage to define the resistor. We want to take 12 minus the 4.7 in the numerator, determine that value, and then divide that by 0.04 amps. You always use the full amps, not milliamps, in the equation. So that gives us 7.3 divided by 0.4, which equals 182.5 ohms. Now that is the resistor, calculated resistor value that will give this brightness of the bulb using a 12 volt power supply. Now if we wanted a dimmer bulb on the 12 volt power supply, then we would go to a higher value than 4.7 and subtract that from 12. So say we wanted to have a voltage drop of 9 volts instead of the 7.3 volts. So we would just take the 9 volts and divide that by 0.04 amps, which gives us a resistance of 225 ohms. Now I have tried that out with a 12 volt power supply, and the bulb is much dimmer than the brightness that you see here. So that's all that's required to determine what resistor value you need. Now you could take a 12 volt power supply and clip in different resistors starting at a higher resistor ohm value and swapping that resistor out into a lower valued resistor until you achieve the brightness you want. But if you don't have a variety of resistors, or a resistor, I can't remember what they're called, but it's got a dial and you can change it to different resistor values. The name is escaping me at the moment, but this is the simple way to do it, where all you need is the power supply of the voltage rating that the bulb is meant for, and a multimeter to determine the amperage, and then you can calculate out the resistance as I've shown. And if you want it dimmer, you increase the resistor value as I've shown here. So I'm hoping that somebody finds this useful. It took me a little bit to remember how to calculate this out, so it took way more time to explain than it did to actually determine. So till the next video, bye for now.